Not every type of cancer is caused by an inherited gene mutation. Many cancers are sporadic and result from exposure to carcinogens such as ultraviolet radiation. UV can lead to DNA lesions, which in return can result in cancers including melanoma. It is not completely understood what factors might impact one's susceptibility to UV-related DNA lesions, or how these DNA lesions are distributed around the genome of melanoma. The impact of these lesions, however, stays in the genome after a mutation has arisen. This study looks at the factors that could impact susceptibility to UV-induced lesions and cancers by creating a genome-wide map of UV-induced DNA lesions. Whilst completing this study, the incidence of UV-induced lesions was investigated to find a link between these lesions and epigenetic features, location within the nucleus, and folding state of the chromatin. In order to create a genome-wide analysis, IMR90 primary fibroblasts were UV radiated with 100 joules per meter squared before being lysed with 1% SDS buffer. They were then treated with various chemicals. Immunoprecipitation occurred in which purified single strand of DNA was repaired via photolasers. Spot blood analysis also occurred. The sequence was processed after repair on an Illumina high-sequence platform, and epigenetic features were analyzed using a Markov model. Epigenetic features that were analyzed included SDAS1 sensitivity, RNA abundance, DNA methylation, and several histone modifications. The Roadmap Epigenomics Consortium products was then used to outline the chromatin states. Analysis then occurred of genome, lamin, melanoma, and a 3D model of the genome was created. This study had multiple primary findings. They found a correlation between genome accessibility and UV lesion susceptibility. Line-rich laminar-associated domains, which were located towards the edge of the nucleus, they found to have increased susceptibility to UV. And they found a correlation between mutation occurrence and carcinogen susceptibility. One of the primary results of this study is the impact of DNA folding and accessibility on UV-related lesions. DNA can be found in two main states: closed conformation, known as heterochromatin, with little transcriptional activity, and the open state, known as E-chromatin, in which the DNA is more accessible. This study found that DNA found in the E-chromatin state is less susceptible to UV damage. This was unexpected, as heterochromatin DNA states are protected from DNase I. These regions are also composed of many repetitive regions known as lines, which were found to have the most UV-resulted lesions in the genome. Laminar-associated domains, known as LADs, near the nuclear periphery show increased carcinogen susceptibility and are enriched in H2KO methyl groups. Heterochromatin-associated proteins such as lamin B1 were looked at to determine if they were susceptible to cancer. Laminar B1 is prominent in the nuclear lamina and interacts with LADs. It was also found to be positively correlated with UV-induced DNA lesions. The results of this study showed that H2KO methyl groups, LADs, and lamin B1 all showed a positive correlation with UV-induced lesions. A solar signature known as a C-10 base pair mutation are often found in melanomas, as well as UV-induced lesions. Figure A shows a direct correlation between DNA lesions and the C-10 solar signature. This shows that susceptibility to carcinogens is correlated to mutation frequency. This study found that the open and accessible EU chromatin is more protected from the UV-induced lesions than heterochromatin. This could be because the sites that are more susceptible are often highly repeated and less transcriptionally important. It could also be an evolutionary protection mechanism which protects the more important genes. The study also found that there were susceptibility differences genome-wide. However, overall, the results show that the epigenomic architecture aids non-cancerous cells decreasing their likelihood of malignancy and regulating the susceptibility of UV-related lesions.